Viewers, you are watching Mathematics channel number Collage. In this video, we will see how to solve homogeneous equations. Homogeneous equations are of the type Ax equals 0, where A is the coefficient matrix, X is the matrix of unknowns, and this is corresponding zero matrix. So we can identify homogeneous equations from the right hand matrix to be a zero matrix like this. So in order to solve given homogeneous equations, we first write them in a matrix form. Please note the constant matrix on the right hand side to be a zero matrix to make these equations homogeneous equations. As usual, we will convert this matrix of coefficients A into a row echelon form by using appropriate row transformations and find its rank. So we perform R2 minus 2R1, R3 minus 4R1 and R4 minus R1. Elements below this leading one, which are 2, 4 and 1, will become 0. So we write them first 0, 0, 0, minus 1 minus 5, minus 3 minus 8, minus 1 minus 5 and rest as it is. Next we will make elements below this minus 1, which are minus 3 and minus 1, 0. So that will give by applying row transformations R3 minus 3R2 and R4 minus R2. First column as it is, then 0 here and here, 7, 0, rest as it is. Now here A is in the row echelon form and we have rank of matrix A to be 3 because there are 3 non-zero rows, which is same as n, the number of unknowns, x1, x2, x3 here. The system of equation has trivial solutions. These three equations give us x3 equals 0, x2 equals 0 and x1 equals 0. These zero solutions are called trivial solutions. Let us see another example of non-trivial solutions. We have to solve these system of homogeneous equations by matrix method. As usual, first we will write them in matrix form. We will make these three elements 0 below this leading one. We will apply R2 minus R1, R3 minus R1 and R4 minus 3R1. These three elements become 0, 1, 1, 2, 2, 1, 1, rest as it is. Next we will make these two elements 0 below this leading one in the second row. For that we will apply R3 minus 2 R2, R4 minus R2. Third and fourth row all elements 0 and rest as it is. Now rank of this coefficient matrix A is 2 because there are two non-zero rows, which is less than number of unknowns 3. The system of equation has non-trivial solution. What does that mean? Number of independent solutions will be number of unknowns minus rank of the coefficient matrix 3 minus 2, 1. Now we can write this one independent solution. From this echelon form we get two equations. From these equations we can write the independent solution by using a parameter t. So we will put x3 equals minus t in the second equation and get x2 equals t by using these two values of x2 and x3. In this first equation we will get x1 equals minus x2 minus 2x3, that is minus t plus 2t equals t. Now we can verify these values by using them in each of these equations. Let us verify the first equation. X1 is t plus x2, which is t again, plus 2 times x3, which is minus t. So here we get 2t minus 2t, 0, verified. You can verify the remaining three equations for the correctness of the values of x1, x2, x3. So our solutions are x1 equals t, x2 equals t and x3 equals minus t, where t is a parameter. Now we will solve one more example with two independent non-trivial solutions. First, equations in the matrix form. To make this 1 and 3 zeros below this leading one, we will apply R2 minus R1 and R3 minus 3R1. These two zeros, first row as it is, and minus 2, 3 minus 2, and repeat. We can make these three elements 0 by applying R3 minus R2. So these three elements 0 remaining as it is. Now this is row echelon form of the coefficient matrix from which we can write two equations. Now rank of coefficient matrix A is 2 due to two non-zero rows, which is less than number of unknowns 1, 2, 3, 4, n equals 4, which implies the system of equations has non-trivial solutions, and the number of independent solutions is this 4 minus this 2, which is 2. There are 4 unknowns and these two equations, so we have to assume two different parameters for two independent solutions. We will put x4 equals t1 and x3 equals t2, so that from this second equation we get x2 equals 3 by 2 t2 minus t1, and putting these values of x2, x3 and x4 in the first equation, we will get x1 equals minus half t2. You can check it for yourself. Now this is the non-trivial solution in terms of parameters t1 and t2, and we can verify correctness of this solution by putting these values in each of these three equations. We will check this first equation, that will give us minus half t2 plus 3 by 2 t2 minus t1 minus t2 plus t1. This t1 gets cancelled. 3 by 2 t2 minus half t2 gives us t2. So this t2 minus t2 gives us 0. Hence the values are verified, and hence the solution. You can verify this solution for the remaining two equations. Viewers, if you like this video, please like, share and subscribe this channel, Number Collage. See you in the next video. Until then, keep watching Number Collage. Thank you.